Hi, algebra students. Today we went over lesson 1-4, solving literal equations and formulas. And the essential question is, how is writing literal equations useful when solving problems? So basically what we're talking about is when we have particular formulas, like the distance formula or area formulas or perimeter formulas, how we can manipulate those before we're given any values to make them easier for us to solve for that particular unknown. Literal equations are just equations that you see that only have variables in them or have multiple different variables that you have to be given information to plug into. And we're gonna work with those, and then hopefully you watch the virtual nerd video to give you a little bit more information about that as well. So what I want you to do is to take a minute and pause the video and fill in these examples for me right now. When you do that, make sure you leave some space for the blanks because we are going to manipulate the equations before we move into those actual solving those equations. So I'm going to scoot it down a little bit so you can see example 1 and example 2. Pause the video and go ahead and copy those into your math journals. And then I'm going to move it down so you can see example 3 as well. And so you can pause the video there and put that in your math journal. When you're done writing those, you can unpause, and I'm going to start going over example 1 right now. So in blank, Sarah is meeting her friends. She is blank miles from the lake. What is the speed she needs to travel to get there? So the formula that we're going to use for this particular example is the distance formula. So distance equals rate times time. Now, I do think that you maybe learned this formula in science class. I don't know that for sure, so I'm going to write this out for you so you remember what those variables stand for. And they are giving us two pieces of information. They are giving us the time here, which we don't actually know what the time is yet, and they are giving us the distance, the amount of miles that she is away from her friends at the lake. And we are looking for the speed. So what is the speed that she needs to travel in order to get there? So we're looking for her rate. Now, we aren't given any information yet, so we need to isolate the variable r in order to manipulate this formula to help us solve later. So in order to get r by itself, we're still going to think about what are the inverse operations that we're going to use and how are we going to apply those to get that variable r by itself. So in this case, r is being multiplied by t. So in order to isolate the r, we do the opposite of multiplication, which is division by t. So when I do that, just like they would if they were numbers, the t's cancel each other out, and I'm left with d over t equals r. So now I have the distance divided by the time is equal to the rate. So now I can give you that information that we're missing. So this is supposed to say in half an hour, Sarah is meeting her friends. She is 6 miles from the lake. What is the speed she needs to travel? So our distance is 6 miles, and our time is half an hour. So we're going to take this information and we're going to plug it into our formula and solve for the rate. So we're going to do 6 divided by 1/2 equals r. And when we plug that into our calculator, 6 divided by 1/2 is 12 miles per hour. So really, you could have solved this by plugging in 6 here and 1/2 here and then dividing by 1/2 to get your 12. But we manipulated the equation first so that our variable is equal to what we wanted to solve for, and then could just plug in and solve for our answer there. So example number 2 says we need to make a rectangular frame as shown below. So here's the rectangular frame. It's this part that we're trying to create, but we're talking about the perimeter of this frame. And we want to know what is the width of the frame. So there's two unknowns, the perimeter and the length. And we're going to use the perimeter formula for a rectangle, which is P equals 2W plus 2L. So 2 times the width plus 2 times the W, 2 times the width plus 2 times the length is equal to the perimeter. So we're trying to find the width. So we need to manipulate this equation so that we have isolated W, and then I'll give you the values for the perimeter and the length and we can solve. So again, in order to do this, we're going to do inverse operations just like we would if there were numbers here. So instead of having this plus 2L being added, we're going to do the inverse, which is minus 2 times the length. Okay, now P and L are not like terms, so I can't do anything with that other than just write them next to each other. So P minus 2L equals 2W. Now this W is being multiplied by 2, so we want to do the inverse of multiplication, and we're going to divide by 2. Now on the left, we have to make sure that we divide everything by 2. So I get P minus 2L divided by 2 equals W. Okay, so now that I've manipulated my literal equation to be equal to what I am solving for, I'm going to tell you that the perimeter of this picture frame is 144 inches, and the length of this picture frame is 40 inches. So we can plug those in for the formula to solve for W. So 144 minus 2 times the length, which is 40, all divided by 2. Okay, now I can do that in my head a little bit. 2 times 40 is 80. If I do 144 minus 80, I think I get 64. I'm going to double check on my calculator. And then I want to divide 64 by 2. And when I do that, I get that W equals 32 inches. So manipulating the literal equations this way allows all the numbers to already be on the same side so that you can just do some mental math or plugging into your calculator in order to get the answer very quickly, instead of plugging in your numbers here and then doing all the inverse operations to solve. Example number 3 says to rewrite the formula for the area of a triangle in terms of H. The formula for the area of a triangle is A equals 1/2 base times height. Now I'm actually going to show you 2 ways to do this. So I want to make sure that I have both here. In order to isolate h, we want to notice what's happening to the h on the right-hand side of the equation. And h is actually being multiplied by b and 1/2 both. So in order to get the h by itself, we can divide both sides by 1/2 b. So on the right, the 1/2 b goes away, and we're left with h equals the area divided by 1/2 times b. Now, this one is just kind of a weird answer. It's actually called a complex fraction because it's a fraction within a bigger fraction. So if you are looking at that and you're like, no, don't really like that, I would rather do it the other way. We're not going to have complex fractions here. So instead of dividing by the 1/2 b to start, noticing that this 1/2 is being multiplied out front, we can actually multiply both sides by 2. And that will get rid of the 1/2 on the right-hand side. So we would have 2a equals b times h. And then we can divide by b in order to get 2a over b is equal to h. So there's no complex fraction in this one. It's just a one fraction so that when you plug in the area and the base, you don't have to worry about that fraction within a fraction. So on the left-hand side in your math journal, I would like you guys to try this one on your own. This is the formula for temperature, converting between Celsius and Fahrenheit degrees. And I want you to try and solve for Fahrenheit. So the Celsius degree is equal to 5/9 times Fahrenheit degrees minus 32. So I want you to solve that for F, the degrees in Fahrenheit. And when you're done, you can check your answer with the picture of my notes that I'm going to post on Google Classroom.